I'm Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. In this series, we're looking into MHF4U, which is Advanced Functions. It is a pre-calculus course here in Ontario. Most of the grade 11 and 12 students will find it very interesting, especially if they want to do calculus after this. Now in this video, we are talking about solving equations and inequalities for rational functions. The questions are selected by my student Chelsea. I am here to guide the students, and what normally happens is they would like to know the best way of solving a particular problem, understand the concepts behind, so that they have the right foundation to solve similar questions. That really helps most of them. Now here, Chelsea has selected few questions. They are all from rational functions. I've broken this down into 3 different videos. In this particular video, we'll discuss how do we solve an inequality which involves absolute value of a rational function. So have a look at it. I hope you find it interesting. Hi Chelsea, how are you doing?
I'm good. How are you, sir?
Very good, very good. So today, what do you want to do?
Today I have a test coming up on reciprocal functions, so I want to cover that today.
Sure, why not? So do you have any questions or doubts which you would like to clear, and or how do you want me to, help you out?
I have some questions that I did from my assigned homework that I had some trouble with, so I wanted to ask you them.
Sure, let's take them first, and then I can actually provide you with some more questions which can help you for your assessment, okay? Why don't you share your questions first? Let's begin from there. All the 3. Perfect. Yeah. So these are 3 different types of inequalities. You are actually doing rational functions. This is extended. We have absolute value of x over x minus 4 to be greater than 1, right? I'll share this a blank screen. So the question was, can you tell me what was the question? Absolute value of?
X over x minus 4 is greater than 1. Greater than equal to 1.
Greater than equal to 1, right? So this is an absolute function. We will first analyze when is this function positive and when is this function negative. Is it okay?
Yes.
So it has a 0 at x equals to 0, right? And it is undefined, so we say vertical asymptote at x equals to 4, correct? Yeah. We are just talking about the function which is x over x minus 4. Is it okay?
Yes.
Perfect. So let's analyze in an interval. So we have x equals to 0 and x equals to 4. Now, let's take test points in the intervals defined. So there are 3 intervals. So in the first one, we'll take an minus 1. Here in between, we can take a value 2. Here we take 5. And we are taking the 2 factors, x and x minus 4. So for negative 1, it is negative. For these 2, it is positive. But when we do x minus 4, in that case, this negative and this is positive. Clear?
Yes.
So we get positive in this interval, negative in this interval, and positive in that interval. Perfect? So what you realize is the given function is negative between 0 to 4, correct? So if I kind of sketch this graph, We have a vertical asymptote at 4, a 0 at 0, right? So this function is basically between 4 and 0, it is negative. And thereafter, it is positive in both the sides. So if you sketch, it is in this interval between 4 and 0, it is negative. So I'm just writing negative here. I'm not drawing, but it is positive in these two intervals. You get the idea?
Yeah.
So that means we need to solve this inequality for the values. This absolute function can be now defined. When it is negative, it will be in this region, negative of this, right? So in the interval from 0 to when x is greater than or equal to 0, but less than or equal to 4, it is negative, right? So this absolute function will be defined as minus of x over x minus 4. Because it will become positive, right?
Why is it minus x? Why is it minus x?
Because it's an absolute value. So let's try to sketch this function. So x over x minus 4 means we have a horizontal asymptote at 1, correct?
Yeah.
Okay. Now, so we know that it is positive in this side, so it is kind of like this. Is that okay now? This is at 1. Is it okay?
Yeah.
We have seen that it is negative in this portion, so the graph has to be like this. Is it okay?
Yes.
Clear? Perfect. Now you realize this is the graph of x over x minus 4, correct? Now if I do absolute value of this, then what happens? If I do absolute value of this, the negative portion becomes positive. So this goes like this. Do you see that?
Right. Yeah.
So therefore, now, when you look at this particular inequality, clearly it is greater than or equal to 1 in two regions, right? So in this region, right? So we have to figure out when is it 1. Do you see that?
Yes.
And of course, x is not equal to 4, that we know. So one of the solution definitely is that x is greater than 4. It is always greater than 1. That portion is clear. Is that okay?
Yes.
We have to now work on the interval between 0 to 4 when this value is negative. Between 0 to 4, which I am trying to do. Is that okay? This should be greater than or equal to 1. Is that clear to you?
Yes.
So that is what we need to solve. Can you solve this now? We know x is positive. Yeah. So we need to now solve this inequality, correct? So we'll bring 1 to this side and then we'll solve. So I'm now using this space. So we have minus x over, rather we'll bring that to the other side, right? So I'll say 0 is greater than or equal to x over x minus 4 plus 1. Is this clear? We'll solve this. 0 is greater than or equal to x minus 4 in the denominator, x plus x minus 4, correct? So we have 0. So now I'll remove this page, clear this away. Is this all clear to you?
Yeah.
So note this inequality. We are going to solve this now, which is 2x minus 4 over x minus 4, right? So we are saying 0 is greater than or equal to 2x minus 4 over x minus 4. This is what we have to solve. Is it okay? So I'm clearing the screen, redoing. So you want to prove that 0 is greater than or equal to 2x minus 4 over x minus 4. Perfect? And we are working with in which domain? X value is between 4 and 0. Is it clear?
Yeah.
0 included. 0 included, correct? Okay. So let's try to. We already have got one solution that x is greater than 4 is a solution, correct?
Yeah.
Now, the other part of the solution we are trying to figure out. let me also sketch the small portion graph for our reference. That is our graph. This is going through 0, right? So we have a graph like this. Is that okay? That is our graph. And we are looking for this value now. So from that value, which is x, we are looking for. So let's solve this. Now this has, you can see 0 at 2, right? And not defined at 4. So this is your 0, and this is your vertical asymptote, correct? So we can take test point from 0 to this place as 1, 3, and 5. And we have two factors, 2x minus 4, other one is x minus 4. So when you plug in 1, you get negative. When you plug in 3 or 5, you get positive. For x minus 4, we get negative, negative, and positive. So when is it negative? We want 0 to be greater. That means we want this to be negative, right?
Mhm.
So it is negative in the interval between 2 to 4. Is it okay? So
Yeah.
this inequality is true between 2 to 4, and therefore we get our solution. That means this point is 2, right? So
Yeah.
our answer is the x value is from including 2 but not including 4, and the other one is from 4 to infinitely large value. Is that clear to you?
Mhm.
That is how we are going to solve this particular inequality. Is this clear to you?
Yes.
Any other questions?
No.
Perfect. So we'll end the class here. Can you please summarize your learnings?
So today we went over how to solve word problems in reciprocal functions. So yeah, we did that. And then we also went over how to use the chart method to find inequalities in reciprocal functions.
And the absolute function inequality was very interesting chart. You know how to sketch a rational function. The negative part becomes positive. Do you see that? And that's why we analyze that portion between 2 and 4, 0 and 4, to find the point 2, which was the point where it equal to 1, correct? And
Yeah.
so we got our solution. That's very critical to understand. So I hope that helps. All the best for your exam or test. See you soon. Thank you.
Thank you.
Thank you. So I hope you found this solution interesting. Wherever it is absolute value of a function, we need to solve the inequality in different domains. As you know, the negative part becomes positive, and therefore finding out the intervals where the original function is negative is very critical. Then you redefine, as we did here, and then once again solve the inequality in that particular domain. That will give you the result as seen in the video. I hope that helps. Feel free to write a comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.